I know that you have been learning about triangles recently, and I found this great app on the Desmos site where we can adjust the vertices of a triangle and see how things change. So I'm going to move around the vertices. Those are the places where the line segments meet at an angle, and I want you to notice and wonder. So, what do you notice? What do you wonder? So one of the things that I noticed is as I moved those vertices, the angles in the triangle was changing, and it made me wonder this. What happens if I were to add the angles, if I were to find the sum of all the angles? So I decided I would do a little investigation, and I want you to tell me what if we notice anything, if we discover. So I have this is a chart, and we're going to record the angles in the first this first triangle that I'm making. So this is triangle 1, and I'm going to record the angle for each one of these for all 3 angles. So let's call this one, angle 1, so that is 51 degrees, and then 83 degrees, and 46 degrees. And so I want to find the sum. I would add them all up. So 1 plus 3 is 4, plus 6 is 10. And then I think it's easy to do 5 plus 1 is 6, plus this 4 is another 10, and then plus 8 would be 18. So I got that nice round number of 180 degrees. All right, let's make a different kind of triangle. We'll make it look really different and see if we get how it's related to that. Let's try, how about, let's do that one. Okay, so we have 91. Actually, let's do a different color. I have 91 degrees in this triangle, and then 58 degrees, and 31 degrees. So those are the 3 angle measurements, and I'm going to add them up and see what happens. So 1 plus 1 is 2, plus another 8 is a 10. That 1 and 9 makes a 10, and 5 and 3 makes 8. What? I get 180 degrees again. That is super cool. Both of those equaled up to 180. All right, let's try one more. We haven't done an obtuse triangle yet, so I'm going to try to make a really funky obtuse triangle. How about really super stretched out one like that? Okay, let's try it. So I have this huge obtuse angle of 162 degrees, and then I have two 9-degree angles. All right, so 9 plus 9 is 18, 19, 20. And then 2 plus 6 in the tens place makes 8 tens. What? I got 180. So for this wonder, what happens if I add the angles in a triangle? It's looking like every single time I will get 180 degrees. So that was a pretty cool discovery, but sometimes it's hard to tell if it's always going to work when we use maybe a computer program like that, and I like to try things with my hands. So I have made 3 triangles. They're all very different triangles, and let's see if we can get the same result by adding the angles on these. So I have my 3 very different triangles. This looks like an acute isosceles triangle because it has 2 equal sides. This looks like an obtuse triangle. And here we have a right triangle. And what I'm going to do is tear off each of those angles. I've labeled them. I'm going to tear them off and then fit them together and see if we see that adding up to 180 again. So let me tear them off. This green one. Tear off this second angle and the third angle, and then I'm going to piece them together. There's A, there's B, and there's C, and look how this angle plus that angle makes a straight angle, which we know is 180 degrees. Let's try it with these other 2. Tear off one angle. This big obtuse angle is kind of hard to tear off. And then there's angle C. They'll fit together the big obtuse angle with these tiny acute angles. And I see it again. Fit them together, I get this straight line of 180 degrees. Let's try one more. It worked. Angle A plus B plus C together makes 180 degrees. And just in case you're not convinced yet, check out this graphic. See how they're taking the same triangle and repeating it and rotating it over, and you see that orange angle plus the green angle plus the blue angle makes 180 degrees, or a straight angle. So the cool thing about knowing that the sum of angles in any triangle equals 180 is that we can then use that to solve problems. If we're given this triangle here and we're told that we know two of the angles are 60 degrees and we're trying to find this missing angle, we can do kind of like a part whole idea. So I know that the 60 plus the unknown angle is going to equal 180. So I'm going to use a related fact and subtract this much from the 180. So together these make 120. If I take that away from 180, I'm left with 60. So this unknown angle would be 60, and this would actually be an equilateral triangle. All right, let's do one more. Over here I see this angle's 45. This angle doesn't have a number, but this box is a symbol. That means it's a right angle. So this is 90 degrees. So I know that the 45 plus the 90 plus the unknown angle is going to give us a sum of 180. So I can, again, do kind of like a part whole idea and put these together. So let's add up the 90 and the 45. And then we're going to take that part away from 180. Got to regroup. Oh, I've got another 45-degree angle. So you can use this new fact that you know to find the missing angle in triangles.